Hello, and welcome to Styles Solutions Live. My name is Ian McNeil. I'm a member of the Styles University team, and I'll be assisting with today's session. We're happy to have you joining us for woodWOP 5.0, Contour Macros Using Z-Values. If you are a woodWOP 5 user, this session is designed just for you. We know how important keeping your production up and running is to your success. Today's web session is one of the many creative ways Styles is continuing our commitment to providing the highest level of service, support, and responsiveness that you've come to expect from us. Styles University is proudly celebrating 30 years as the industry's only nationally accredited training program. Our learning events provide comprehensive, hands-on technical and applications training designed to equip manufacturers with the skills and knowledge needed to thrive. We're happy to be joined today by Phil Racy, Senior Instructor with Styles University. Phil has been a member of the Styles family for 22 years, 19 of those he has spent within our education department. Phil's decades of experience in CNC equipment and multiple versions of woodWOP programming software make him a leading expert in today's topic. Phil is also the author of our CNC 110 course, woodWOP 5.0 Programming, available now at Styles University Online. Please know we're also joined today behind the scenes by Styles University instructor Manny Silva, who will also be available to answer your questions. You can submit questions for Phil or for Manny using the Q&A window at the bottom of your screen. We'll be sure to address those questions at the conclusion of the session, but please feel free to enter them at any time. We will not be using the raise hand feature of Zoom, so please submit all questions via text in the Q&A window. This time I'd like to welcome Phil back to Solutions Live. Phil, how are you?
We're doing good. How are you?
Doing just fine, thank you. Happy to have you joining us today. If you're ready, you can go ahead and share your screen and we'll get started.
Okay, good afternoon, everybody. One of the questions we get quite often is how do we move the router motor or router tool in the Z-axis? Predominantly for three-dimensional door panels, fluted columns, really whatever application you may need. So again, we're going to talk about moving the router motor in Z. So one of the restrictions we have within woodWOP 5.0 is that it really is a 2.5 axis program, which means that we can move in a straight line or an arc in the XY plane, but anytime we move in Z, it's going to be a straight line. woodWOP 5 and earlier just really didn't give us the capability of producing an easy arc in Z. You can always design the router movement in the Z dimension by using a series of straight lines that decrease and then increase. You can calculate, but it's pretty heavy in the math in order to be able to get a router to move in a true radius in Z just within the world of woodWOP. So again, we'll talk about how do we move the router motor in Z. So again, we're specifically talking about woodWOP 5.0. We do have some other videos for the latest version of woodWOP. Please seek those out if you have one of the newer machines that has the newest version of woodWOP. So let's talk about 5.0 specifically. So when you draw contours in 5.0, F7 allows us access to the tools. So the vertical drills, the horizontal drills, the grooving saws, the router motor, router tools, but we have to click F6 in order to access the contour macros. So anytime we do this, F6 leads us off with a start point. So every contour has to have a start point. You'll notice in this illustration that the start point is the bullseye image, but the lines, the arcs, and the edits below that are grayed out. So you don't even have access to the lines until you create the starting point. So a little bit of review. When we design the contour starting point, we design the point specifically in an XYZ dimension. So if you're doing a flat line design, you establish where the contour is in Z, and then we wouldn't have to worry about moving it after that. The start point is also the only macro, the only element within the contour that is designed on a coordinate system. So again, we talk coordinate systems, the four corners of the panel, 0, 0, 0, 1, 0, 2, 0, 3. But you have the ability to create your own coordinate system, position that on the board. If you attach the contour to that coordinate system, you can then rotate the shape, which is a very valuable tool. So again, the start point is going to ask for a location in X, Y, and Z and the coordinate system. Now, you have to hit the check mark in order for this to show up in the program. So it's an approval, it's an acknowledgement that you want that start point or the line. So this is in any application. So even when you get to the drills, you can program all the drill parameters, but you have to hit the check mark for it to show up on the program. So when it comes to lines, you have two options. The most common line is the endpoint. It's going to ask you where do you end in X and Y, but we have the ability to turn on the additional parameters and select a Z move. The other option is to determine how long is the line and what angle are we cutting. So again, this is a valuable tool. I'm not certain that it's used that often, but again, it's a tool that's available for you. And again, we can make Z-axis moves with that. So let's talk about Z-axis moves. You have two options. You can tell the router to end the line at some point in the Z. Probably use the most. It's definitely the safest move. We'll talk about what happens when we pick the second option, which is pitch. Pitch is an angular move. It's rise over run. But you have to be very careful. You're telling a line to move in a specific dimension in X, Y, and depending on how long that line is, your angle could project the tool well below the panel. So again, I'll show you some examples. Just have to be aware, we don't use pitch very often, but if you know that you have an angular move, you already have that number, so we can use that. So here's an example. We have the XY top view, so we have a start point, and then I produce two lines. So you can see the first line is black, the second line is blue. So that's whichever line you're highlighted on. The first illustration is Z end. So I told the router to start at the thickness of the board, and then I ran down to a Z dimension of 5 millimeters. So that's 5 millimeters above the spoil board or above the vacuum pods. And then I produced a line that went back up to the thickness of the panel. Okay, it's a safe move. Again, we'll get into some tooling specifics, but if you look at the second illustration, this is pitch. Produces almost the exact same design, a little bit different in my Z endpoint, but this is a -15-degree angle. Okay, I know that value. So again, when I design in the 3-dimension, I use the Z commands, I definitely use the view and I look at the front of the panel. I need to see where that line is ending in Z for machine safety for the tooling. So when we talk about arcs, so you have 4 arc options within 5.0. Probably the first one, the arc radius and endpoint, is used the most. The arc 3-point is probably used second. So you can define the endpoint of the arc and what dimension is for the middle point. Very, very useful in creating things like valences. So I know the middle point of the valence, either the rail width or the height of the arc. I don't have to do any mathematics. I don't have to do any algebra to figure out what the radius is. Now the middle two, they're very good for certain applications, but they certainly aren't used very often. So the arc center point endpoint is actually asking you where is the pivot. So imagine drawing an arc using a compass. You have to know where that pivot point is. So either you have to calculate that or you have to know that. So again, it's a useful tool, just not used very often. Along with that, the third option, what is the direction of the arc, clockwise or counterclockwise? What's the endpoint? And what is either the starting or ending angle? Again, if you know the starting angle, that's great. If you know the ending angle, but without having to calculate those, we're back into the first or the fourth arc. Now, again, we can do z-axis moves in an arc. The last function you have within the contours are the edits, rounding, chamfers, and splits. So we don't have a lot of control. The round is just going to ask you for a radius. And then the chamfer has multiple options. What's the length of the chamfer? What's the effacement? How much do you want to shorten off of each end? So there's a lot of tools within the chamfer. And then the split is just the ability to take a contour line and cut it. So you can cut it at a percentage, you can cut it at a specific point. We may want to do this just because when the design was created, the start point really wasn't in a good spot. So we'll pick a long line and we'll actually cut that line in half. Once we've cut it, then that becomes a design element. So I can tell the router where to start in the contour split. So again, let's talk about a caution. So here's two examples. I've got a pitch of negative 15 degrees. The top one is on a panel that's 50 millimeters thick. And then I did the exact same contour on a panel that's 25 millimeters thick. It doesn't take a woodWOP professional to realize that the 25 millimeter panel is going to be a very dangerous program to run. But there's a way that we can protect ourselves from this. The first one is definitely look at the front or the side view to actually see where the contour is moving in that Z element. So let's talk about how we protect ourselves. When you set up your tool, it's going to ask you for a length of the tool, that's the total. It's going to ask you for a collision length. For most of these applications, the collision length is the bottom of the tool where the tool's cutting. It gets a little more involved when you're talking profiling tools. But the working length is how much geometry do you have to work with. So if you don't set the working length correct, then the NC generator loses the ability to help protect you. So here's an example. The top view shows an arc, and then we have the Z end. I'm ending at the bottom of the panel, or Z0. But I did the same thing with the arc, only this time I did the pitch move, and I did a negative 15 degree pitch. So here's my insert tool, and it's highly recommended if you're going to do these raised panel doors or these type of applications. Try to get an insert tool. That way, when you replace the insert, the angle is always correct. If you get a carbide tool, every time they grind it, if they didn't get the angle exactly correct, whether it's a 45, a 90, or a 60 degree tool, you're going to have to go back and recalibrate that tool to make sure the corners are square. So again, try to get insert tools. It just makes them faster to get back into production. You don't have to recalibrate. So here's an illustration of what happens with the working length. We know that we can follow down to this point, and at the top of the insert, that is the end of my working length. So in this case, if I had this tool set up and I push this through the NC generator and woodWOP, the machine's going to come back and tell me your tool's too short. You can't do this. But again, if I had lied to the machine and incorrectly determined the working length, I could easily take this tool and bury it into the panel. At the best, I would just probably ruin the tool. But I could get to a position where I could push the collet nut and the whole tool holder into the top of the board. And now we're talking possibly misaligning the router motor, damaging the Z-axis ball screw. So again, Z-axis moves, you need to pay attention to what you're doing. They're not hard to do, but there's a few things you need to look at. The last thing we need to talk about is what do we do with the Z dimension? So when we're cutting with a straight up shear, down shear tool, we can tell the router motor where to cut in Z, -2 millimeters because we're on a vacuum pod machine. We want to cut 10 millimeters above Z, but we're not moving in the Z dimension. So the tool stays at that position. Anytime we do a Z dimensional move within the contour, our Z dimension on the router tool has to be relative. We have to put the @ symbol in there. If we don't, if we just put it at 0, then the tool's going to plunge to Z0, absolutely. It's going to follow the contour, But when it gets to the corners, it's not going to move up and down in Z. It's just going to move in a flat line to the corner. So again, anytime we do a Z-axis move, the tool must be relative to the contour. So in this case, we put at 0. If you want to cut a millimeter deeper, you could put at -1. So again, we have that ability. So this is really what we're trying to do on this raised panel door. We want the tool to move to the corner, and then we have to do an X, Y, and Z move. My preference is to set up the parameters in the variable list so that I can control this very easily. So what we're ultimately looking for is this perfect corner. So when we make that XY move, if the XY movement is too small, then the tool comes up in Z, the corner is going to tend to bow in. So if you see the corner starting to have a small radius inward, we need to make that XY movement longer. If you see the corner starting to flail away or radius out from the corner, then your XY dimension is too long. So again, if we make a variable just for that dimension, it makes it much easier to calibrate this. And once you get one corner perfect, then naturally the other 3 corners are going to fall in line. So here's my variable list. So you'll notice I have a V tool and a V feed rate. I want to be able to change that V point tool. So maybe I'm going with a 45-degree tool, maybe it's a 60-degree tool. The 60-degree tool, you may have to do a little calculation to figure out what that XY movement is. I want to control the feed rate. Am I cutting this into a plywood door? Am I cutting it into hardwood? Am I cutting into MDF? I want to be able to control that feed rate. So we want to be able to control in inches, the length, the width, and thickness of the panel. And then I have 3 very important variables for me. RS. So in this case, I decided to make a panel that was completely balanced. So rather than having style left, style right, rail top, rail bottom, I just made a variable for rails and stiles. So whether they're 2 inches or 2.5 inches, I change one number and the whole drawing changes. I have a profile depth. How deep do I want that tool to provide that profile? So in this case, we're using a 45-degree beveling tool. I want that profile to be 1/2 inch deep. And then the last one we talked about, I need a variable for XY. How do I move the tool in the corner? How do I produce that up movement? So let's talk about getting into the board. Most door manufacturers do not like the on and off the fly option. On and off the fly works great for panel sizes, shelves, things like that. But what happens in the door is our V-point tool is going to ramp in on the on and off the fly. It's going to do an absolute stop at the bottom, a couple of milliseconds. But there's a little bit of vibration. And then the tool is going to go around the door and produce all 4 corners. And then it's going to come back to that same location, do an absolute stop, and then ramp out. Well, that absolute stop and that vibration is going to potentially cause a dimple. And if it's a paint grade door or if it's going into a membrane press, that dimple has a really good chance of showing up. So most door manufacturers produce their own ramp in and ramp out. So in this illustration, I have a starting point and an ending point, and then there's a flat between them. So if you look at my start point, I'm at 1/2 the panel length and I backed up 100 millimeters. The Y is set at the width of the board minus the rail width, and I'm at the top of the panel. When I make the ramp in, I move 75 millimeters. So relative at 75, Y stays at 0, and now I go thickness minus the profile depth. So that produces my ramp in. I cut around the door, and then when I come back, I end up at 1/2 the panel length, and then I move 75 millimeters while I'm coming up in Z, and that's my escape. So again, the caution at the bottom, when we assign a tool to this, your Z dimension for the tooling has to be a relative command. So let's talk about the corners. So in this case, I'm going to ramp in. When I get to this corner, I'm going to move positive in X at XY, but Y has to go negative. So at XY, at minus XY, and I come up to the thickness of the board. Now I need to reverse and come right back down to the bottom. So in that case, X goes negative, Y goes positive, and we come back down at minus the profile depth. That's how you do a corner. It just depends which corner you're in and whether X moves positive, Y moves positive. In this case, X moves negative, Y moves positive, and the fourth corner, X goes negative, Y goes negative. It's not difficult, but again, it's an extra couple steps when we're programming this door. So what I want to do is I want to demonstrate how to make this this Z-axis move on the drawing. So I'm going to start my woodWOP program. So again, here's my variable list. I kept it up, but I have no contour. So here's my V tool, my feed rate. In this case, the door is 32 inches by 15, 19 millimeters thick. Then my rails and stiles are 2 inches, half-inch profile. And in this case, I'm going to try the half-inch move. So again, when I do my test cut, if I see the corner bow in a little bit, maybe I want to take that XY dimension and make it 0.55 and then do another test. But if it's an insert tool and it's a high quality tool, then in theory, XY and profile depth should be the same number. So let's program this door. So I have to go into F6. That brings up my contours. So I'm going to pick up the start point. And we're going to go L divided by 2 minus 100 millimeters. This is going to be width minus rails and stiles. And we're starting at the thickness of the panel from coordinate system 0, 0. We hit the check mark. Here's my contour. Now, if I go to F9 and look at the XZ view, I can look at the front of the panel. So here's my contour in the Z movement. Okay, so I need a straight line. So now I pick a line. I know the endpoint. So X is going to move at 75 millimeters. Y stays where it is, 0. But I can't use the Z options. So I go on the green plus sign, my additional parameters, and I pick Z end. I know where I want the tool to end. In this case, I'll just use a relative command at minus PD. So there's my ramp, 75 millimeters long, down to a half-inch profile, leaving a 1/4 inch at the bottom. So now I need to go to the corner of the panel. Okay, so let me go back to the top view. Pick up a straight line again. So now we're going to end at length minus rails and stiles. Y stays at 0. I'm not doing a Z-axis move, so I don't need to turn it on. Okay, now we have to do the corner. So from our 0 point of the panel, we know that X needs to move positive, Y needs to move positive. So we grab a line. We're going to turn on the additional parameters, go to Z end. So now X goes at XY, Y moves at XY, Z goes to thickness. So very short line. Now if we look at the front of our panel, we now can see the line moving up in Z. So here's the easy way to do this. When you go up in Z, you have to come right back down the same line. So I'm going to copy and paste, open up this line, and now X goes negative, Y goes negative, and we tell it to go at minus PD. When you update the screen, my router is now going to go up in Z and back down in Z. We have to do that in all 4 corners. So the next thing I need, a straight line. X stays where it is at 0. Y is going to go down 2 rails and stiles. Now we need to make that Z-axis move again. So again, we pick up the line. Now what does X do? X has to go positive, but Y is going negative. So at XY, at minus XY, and we have to turn on Z. Z is a dangerous move, and the program wants to make sure that you physically go in and pick it. Otherwise, it would show up all the time and you could forget what you were doing, which could be dangerous for the tooling on the machine. So now we came up in Z, copy and paste. Now X is going to go negative, Y is going to go positive at minus PD. So again, we look at the front of the panel. I'm always checking to make sure that the Z dimension makes sense. Okay, so now we have to come all the way down to the starting corner. So we go back into our lines. Now we're going to end at rails and styles and rails and styles. Again, there's no reason to turn on Z. We're not doing anything in the Z axis. So now we need another corner. In this case, X and Y both go negative. Minus XY. Minus XY. Go in and turn on Z. Go to the thickness of the panel. And we copy paste. Now, they're both going to go positive. And at minus PD. So again, look at the front of the panel just to make sure that I don't have to come back and fix anything. So here's my ramp in, first, second corner, come all the way up here. Here's my third corner. We have one more corner to do. So we need a straight line at 0, W minus RS. One more corner move. In this case, X goes negative, Y goes positive. And turn on Z. Copy and paste. So now X is going to go positive, Y goes negative at minus PD. Okay, so last two lines. So we don't want this line to end where we ramped in. We want to overlead that. So tell the line to end at L divided by 2 at 0. So let's look at the front of my panel. The ramp in comes here, but this line has overled by 25 millimeters. Now we're going to pick a new line. X is going to go at 75 millimeters. Y stays at 0. Turn on Z and go to the thickness of the panel. That's my raised panel door. So if we want to put a flat tool on there, I just create a rectangle in the middle so that my flat tool can cut. I don't need the corner moves for that. And then I could possibly use that same inside shape without the corners to put a profiling tool. So I would have a raised panel bit. My order of operations, I would do the flat tool, then I would do the V point, and then I would do the raised panel. That way I'm not running the risk of having the tools overcut each other. Okay, so now we need to put a tool on this. So we go back to F7, pull up the router bit. Now this is an open contour. The start point and end point don't touch. So we have to tell it where to start. So contour 1, element 0, and we want to end at contour 1, element 15. We do not need on and off the fly. We created our own ramp. So we're going to come in vertically. It's a V-point tool, so we want to cut on the center line, and we want to leave vertically. Now here's the big one. If I don't select this as relative, then the tool's going to stay absolutely at 0. So we're going to go at 0. Feed rate, so this is now going to be V underscore feed. And my tool number, V underscore tool, we hit the check mark. So one other disadvantage to 5.0, and it's just that they didn't give us this ability, I can view the tool from the top, but we don't have the ability to view the tool from the edge. So if I go back to the top view, so here's my router tool. Control H turns that on or off. Control J walks it forward. And Control G would walk it backwards. So again, not a difficult thing to do. We've seen this also used when making fluted columns. So rather than taking a coving bit and plunging at the start point, going to the end and then lifting, that plunge generates a tremendous amount of heat. So in a fluted column, we could actually see that tool pass that heat onto the part. And if anybody's ever cut cherry or Eastern hard rock maple, they burn if you look at them wrong. So one way to help limit the amount of heat transference is to do a very short ramp in. It kind of adds a very cool architectural look. If you make the ramp a little bit longer, it makes the top and bottom of the fluted column more of an arrowhead. But we've seen that, we've seen it in the raised panel doors. So there's multiple applications as to why we would pick the Z-axis move in this in woodWOP. What do you think, Ian?
Sounds great, Phil. Thank you so much. At this time, I just want to remind all of our attendees who are with us that if you have any questions related to woodWOP 5, contour trimming, or any of the topics that Phil discussed today, you can submit those using the Q&A window at the bottom of your screen. I just want to make a quick acknowledgement. We apologize if you experienced any inconsistent audio feeds during the session. We'll work to improve that quality for the recorded version that we'll send to you via email. So again, we apologize for that. And if anything was unclear, please address it to us using the Q&A window, and Phil can elaborate on that.
So Blair's got a question.
Yeah, please take that one, Phil.
Blair asked the question, does this also apply to woodWOP 7? Absolutely. Virtually the same functionality. woodWOP 7 does give us some additional tools. So if you have specific questions about 7, you can contact myself or Manny. We can definitely help you with that. One of the applications that 7 does give us is that we have the ability to draw a contour on the vertical surface and do an arc there, a true radius, and then put a vertical tool on that. That really came out with the version in woodWOP 7. But if you have more questions specifically about 7, please reach out for us. We can help you out with that.
Yeah, in addition to that, Blair, just wanted to let you know that we actually have done a webinar through the Style Solutions Live program regarding this feature in woodWOP 7. So if you'd like to go to styles.live, you can enter that into your web browser, styles.live. And scroll, you can find woodWOP 7. It's called Contour Trimming in the Z-Axis. You can find a full-length webinar that Manny instructed about 3 weeks ago. You can find that recorded version there to access more specifics and particulars in woodWOP 7. Phil, a question came in here via the chat window. Are helical ramp-ins possible?
Absolutely. Hang on a minute. I might even have one.
Yeah, we'll keep you on your screen there so you can show any kind of demonstrations you need to do.
Well, I can do one very quickly here. So let's go to File, New. We're going to make this panel square. So we'll make it 600 millimeter square. We'll make it a little bit thicker, 30 millimeters. I'm going to give myself an edge. So border width, BW, and that'll be 50 millimeters. So again, we go into F6, grab my start point. So L divided by 2, and border width, and the thickness of the panel. Okay, so I'm just going to do a helical to the bottom. But if you needed to do more radiuses to get, if you truly wanted to make this more of a screwing operation to the bottom, we can do that. But very quickly, I just grab the arc. So where are we ending? We're ending at the same place, L divided by 2 and border width. What is the radius? Well, that's going to be L divided by 2 minus the border width. We're going to do a large radius, but I also want to go into the additional parameters and turn on Z. So where do you want to end? Z0. So we're going to do a large radius in the clockwise direction. So we hit the check mark. There's my full circle, but if I go to the view, I started here at the thickness of the board. In one swift motion, I ended up down at the bottom of the panel. So again, when you go to your router bit, it's still an open contour. Tell it where to start, where to end. Vertical in this case, maybe I want to cut to the inside of that. So I would cut left, vertical out, and again at 0. Select the tool number. Now, if you wanted to make more radiuses in there, then your Z dimension would change. So if I go back into my contour, now I want this not to end at Z0, but T divided by 2. So then I can copy and paste. This arc then ends at 0. So that quickly, I was able to take one contour, take it to half the panel, and then take the second one from that position to the bottom. Hopefully that answers that question.
Yeah, the person who asked, the person who asked that question said thank you, Phil. So that was a great explanation of that complex procedure pretty quickly. I just want to give one more opportunity for those of you who are with us to pose any questions to Phil, again, using the Q&A window at the bottom of your screen. Seeing that there are none, I will try to move to close us here.
Okay, so I'm going to stop sharing there, Ian.
Yep, I will take over from you. Again, thank you, Phil, so much for sharing your expertise with us again. Just a reminder for all of you, again, this presentation has been recorded and we will share it with you via email. And we will do our best to work on fixing those audio issues. So if anything was unclear to you during the live session today, we can try to fix that when it comes to you in a recorded link. Just a couple of points before we end today. I just want to let you know that Phil is available for more questions. You can see his email there, pracy@stylesmachinery.com. If you have anything specific to ask him, maybe relating to your particular production as it runs now, Phil is happy to answer those questions if you just shoot him an email at the address seen on your screen there. Phil is also available for a personalized version of today's session. So if you'd like to have Phil take over control of your woodWOP 5 and have questions and answers specifically about your applications, equipment, and products, he is available for one-on-one web sessions. And you can contact us at classes@stylesmachinery.com to explore those opportunities. Again, it's the address you see right on your screen there, classes@stylesmachinery.com. We'll be able to set up a one-on-one web session with you and Phil at your earliest convenience. Also, Styles University Online is our online learning platform. We're currently offering 7-day free trials for this platform, and it allows us to bring the expertise of our instructors like Phil directly to you whenever and wherever you need it. So if you're interested in this, we are happy to start a 7-day free trial with you where you can find a class like CNC 110, the Introduction to woodWOP 5 Programming that I mentioned at the beginning of this session. Phil created that class and it's available now to take during that free session. So please contact us using the email you see there or call us at the number on your screen. And if you'd like to visit more and learn more about Styles University Online, you can follow that address there, stylesuniversity.com/SUO. One last announcement. We just wanted to let you know that our Styles Manufacturing Solutions seminar is moving online for the first time ever. This one-of-a-kind event that has inspired thousands of in-person attendees is going digital, bringing unique technology experiences, fresh business growth ideas, and engaging network opportunities directly to your screen. We're coming to you the week of May 18th through the 22nd. and we will have upwards of 10 presentations available for you to select from. Registration and a full schedule of events is available by accessing the site at the bottom of your screen there, stylesmachinery.com/MSS. Again, stylesmachinery.com/MSS. That's a free event for you to attend, and it's a very, very interesting and exciting way to see our machines up and running, even in the current circumstance we find ourselves in, away from the chance to do this as a group. Thank you for joining us today. We appreciate your attendance, and please know again that this has been recorded and will be sent to you for visual or to see later. This web program, Solutions Live program, is running every Monday, Wednesday, and Friday at 1 o'clock. So again, we hope to have you join us this coming Wednesday and Friday, again at 1 o'clock.